Hello students, myself K. Manindra Singh. Today I will be discussing pair of linear equation in two variables. In today's class, I will discuss about consistency and inconsistency of pair of linear equation in two variables, and also algebraic method of solving linear equation in two variables. So let us first discuss the consistency, inconsistency of linear equation in two variables. We know general form of pair of linear equation in two variables are a1 x plus b1 y plus c1 is equal to 0, a2 x plus b2y plus c2 is equal to 0. So this is the general form of pair of linear equation in two variables x and y. So a1x, this is the coefficient of x is a1, coefficient of y is b1, and the constant term is taken as c1 for the first equation. The second equation, the coefficient of x is a2, coefficient of y is b2, and c2 is the constant term. So when this equation is said to be consistent, the meaning of consistent is when equation having solution. Consistent means consistent. System of equation is said to be consistent if it has solution. If it has solution, so when it will have solution, number one, if a1 by a2, that means coefficient of x in first equation divided by coefficient of x in a2, coefficient of x in second equation equal to b1 by b2. If a1 by a2 is not equal to b1 by b2, that means coefficient of or ratio of a1 and a2 is not equal to ratio of b1 and b2. If it is not equal, then system of equation we get unique solution. We have unique solution. That means we will get a pair of linear equation. Okay, we have got a pair of linear equation. It will have a unique solution if a1 by a2 is not equal to b1 by b2. With the help of example, I will explain later. Now, second condition is if a1 by a2 is equal to b1 by b2 is equal to c1 by c2. If all these ratios are equal, okay, a1 and a2, b1 and b2, c1 and c2, if ratios are equal, if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then system of equation have infinite solution. It will have infinite, and in these two cases indeed they are called consistent. It is called consistent. In that case, system of equation are said to be consistent. In these two cases, if we get a1 by a2 is not equal to b1 by b2, then system of equation will have unique solution. So it has solution. So consistent. Here also we have solution, although here it is infinite solution, but still we have solution, then also we call it consistent system of equation. System of equation is said to be consistent. And also this, when this happens, if A1 by A2 is equal to B1 by B2 is C1 by C2, indeed they are called also dependent said to be dependent system of equation. System of equation are said to be dependent pair of linear equation. So if A1 by A2 is not equal to B1 by B2, then system of equation have unique solution. If A1 by A2 is equal to B1 by B2 is equal to C1 by C2, then system of equation have infinite solution. In both the cases happen, then we say the pair of linear equation to be consistent. Now when it is inconsistent, if it is inconsistent, if third one, it is inconsistent, third one, if A1 by A2 is equal to B1 by B2, but it is not equal to C1 by C2, then the system of equation have no solution. So this system is said to be, in that case, system is said to be, it is said inconsistent. It is said inconsistent when there is no solution. No solution, then the system of equations is said to be inconsistent. So let us consider one example here. Say twice x plus 3y plus 5 equal to 0 and 5x minus twice y plus 1 is equal to 0. Whether this system of equation is consistent or inconsistent, if we see here, first equation, this is A1 is equal to, here we see A1 is equal to 2, B1 is equal to coefficient of y, it is equal to 3, C1 is equal to the coefficient constant term, that is equal to 5. In the second equation, A2 is equal to the coefficient of x is A2, so A2 is equal to 5, B2 is the coefficient of y, which is minus 2. We have to take the minus here, minus sign, so minus 2, and C2 is equal to 1. Now A1 by A2 is equal to, we say, it is equal to 2 by 5, and B1 by B2 is equal to 3 by minus 2. Thus, we see that A1 by A2 is not equal to B1 by B2, as 2 by 5 is not equal to 3 by minus 2, so A1 by A2 is not equal to B1 by B2. So system of equation is consistent. We say it is consistent. It has unique solution also. The system of equation have unique solution. It has unique solution as well. System of it have unique solution. System of equation has a unique solution. So consistent and system of equation has unique solution. since A1 by A2 is not equal to B1 by B2 in this case. Again, let us consider another case, another pair of linear equation. Say thrice x plus 5y plus 7 equal to 0 and 6x plus 10y plus 14 is equal to 0. So here you see A1 is coefficient of x in the first equation, that is equal to 3. So A1 is equal to 3, B1 is equal to 5, that is coefficient of y in the first equation, B1 is equal to 5, C1 is equal to 7, A2 is equal to 6, B2 is equal to 10, and finally C2 is equal to 14. And you see A1 by A2 is equal to, now you see A1 by A2 is 3 by 6, which is equal to half. Then B1 by B2 is equal to 5 by 10, so which is equal to again half. C1 by C2 is equal to 7 by 14, so which is again equal to half. So in all the cases, A1 by A2 is equal to A1 by A2, B1 by B2, C1 by C2. In all the cases, they are equal to half, so they are equal. So therefore, A1 by A2, therefore, you see that therefore A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So the system of equation has infinitely many solutions and it is consistent. So the system of equation is consistent. We say it is consistent. Also, the system of equations have infinite solution. So it has infinite solution. So we have discussed when it has a system of equation have unique solution, when the system of equation have infinite solution, and now we'll see when the system of equation has no solution. Let's consider this system of equations. Say twice x plus 3y, twice x plus 3y minus 5 equal to 0, and 4x plus 6y plus 5 equal to 0. Here, you see again, here A1 is equal to 2, B1 is equal to 3, C1 is equal to minus 5, A2 is equal to 4, B2 is equal to 6, C2 is equal to 5. Now, A1 by A2 is equal to 2 by 4, which is equal to half. B1 by B2 is equal to 3 by 6, which is again equal to half, and C1 by C2 is equal to minus 5 divided by plus 5, which is equal to minus 1. So we see that A1 by A2 is half, B1 by B2 is also half, and C1 by C2 is minus 1. So we can conclude that A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. So therefore A1 by A2 equal to B1 by B2 but not equal to C1 by C2. So therefore system of equation has no solution, and so the system of equation is inconsistent. Therefore the system of equation have no solution and they are inconsistent. The system of equation is inconsistent. So here we see the cases, all the three cases when the system of equation are consistent or inconsistent. We can check in this manner. Once the system of equation is consistent, then it has solution, and how the graph looks like that also a little bit we'll discuss here. I am not drawing the graph, but just I will say how the graph will look like. Unique solution, when unique solution, in case of unique solution, the pair of linear equation will give two lines. So lines will intersect. Lines will intersect. In that case, lines will intersect. Unique solution means lines will intersect. Two lines will intersect. Two lines will intersect. If infinite solution, two lines, in that case, two lines are indeed, they will become one line. They will become one line. Two lines will become one line. The two lines are, we say in that case, coincident or overlap. They will overlap. Overlapping line will be there. Overlapping line will be there. If infinite solution, the lines will go like this. Lines will be one line and another line will go like this. In this case, both the lines will be overlapping, and in this case lines will intersect. If we draw the lines in the graph paper for the equations, then they will intersect. We can check that. And finally, if no solution, in case of no solution, lines are parallel. Lines are parallel. In that case, two lines are parallel. In that case, two lines are parallel. No solution, lines are parallel. Infinite solution, two lines are coincident. If unique solutions, lines will intersect. So this is how the property of the lines, that is also asked in the exam. Now once the consistency, inconsistency of pair of linear equations are understood, now we are ready to find the solution of linear equation in two variables by algebraic method. we have already solved graphically. So today we'll solve by algebraic method. So by algebraic method, we'll solve system of linear equation in two variable. For that, let us consider two example. One example, say particular example. Say example here, say thrice x plus 5y minus 1 equal to 0 and 4x plus y, 4x plus y to 0, something like this. These are the pair of linear equation. Thrice x plus 5y, thrice x plus 5y, sorry, thrice x minus 5y, sorry, so I'm changing the equation. Thrice x minus 5y minus 1 is equal to 0 and 4x plus y minus 9 is equal to 0. So these are the two equations which we are going to solve algebraically. So algebraic method, there are first method that is called substitution method. So we'll discuss this substitution method first. How this substitution method is done. So from before solution, so first we write the solution here. Solution thrice x minus 5y minus 1 is equal to 0. We put this as number 1, and another, this one, 4x plus y minus 9 equal to 0 as number 2. So these are the two equations. We will put numbering first. From any of these, we'll get the value of x or y. You can use equation number 1, you can use equation number 2 as well. Equation number 1 and equation number 2, both you can use. Using any one of them you can use, and you can find the value of y or x. Y in terms of x or x in terms of y. From here, if we take y, then y is equal to, we see that y is equal to what? Y is equal to minus 9 will be transposed to right side, 9 minus 4x. Okay, if we take this equation below 5, and if we take value of y from here, then we get 5y is equal to thrice x minus 1. So this implies y is equal to thrice x minus 1 by 5. So we can use any one of them. So I am using here from second one. Second equation, from, we write like this, from equation 2, y is equal to, y is equal to 9 minus 4x, y equal to 9 minus 4x. Y is equal to 9 minus 4x. After getting y equal to 9 minus 4x, now substitute this y, value y in this equation number, because we have got from equation 2, you see, very careful, we have got from equation number 2 value of y. Yes, we got from equation number 2, so we will substitute this value of y in the equation number 1. From equation number 2 we have got this one, y is equal to 9 minus 4x. So substituting the value of y equal to 9 minus 4x in equation 1. Because we have got 9 minus 4x from equation number 2, so we'll substitute this value equation number 1. If we have got the value of y from equation number 1, in that case we'll substitute 8 in the equation number 2. So we got, after substitution, we got 3x minus 5. In place of y, put it inside the bracket, and in place of y we write 9 minus 4x minus 1 equal to 0. Now this has become a linear equation in one variable, and which you can solve very easily. So let us solve. 3x minus 45 minus plus 20x and minus 1 is equal to 0. So this implies 3x plus 20x is 23x minus 45 minus 1 is equal to 46 is equal to 0. This implies this implies 23x equal to 46. So this implies x is equal to 46 divided by 23, which is equal to 2. So value of x we have got 2. Now x is equal to 2 we have got, and x equal to 2 we will substitute here. Y is equal to 9 minus 4x. So therefore y equal to, you put here, y is equal to 9 minus 4 into x, that is value of x is 2, 4 into 2 is equal to 9 minus 8, which is equal to 1. So value of x and y we have got as 2 and 1. So answer, we write x equal to 2, y is equal to 1. So this is the method for solving pair of linear equation in two variables by algebraic method. In that algebraic method is substitution method. This method is called substitution method. There are more methods. Another method is there, elimination method, and another is there, cross multiplication method. Now let's solve this same equation by another method called elimination method. So same equation, I'll give same pair of linear equation. I'll solve by the method called elimination method. So let us write the equation here again. 3x minus 5y minus 1 equal to 0, and 4x plus y minus minus 9 is equal to 0. So these are the two equations which we will solve with the help of another method called, now we'll do which method? We'll do this one. This is number 2, method 2, elimination method. By this method I'll solve this equation, elimination method. Earlier solved method is called substitution method. Now the method I am going to adopt is elimination method. Solution: First I'll write the equation 3x minus 5y minus 1 equal to 0. 4x plus y minus 9 equal to 0. And here I put this as equation number 1. I put this as equation number 2. So what I have to do, I will equate the coefficient of x or coefficient of y. Any one. So let us equate the coefficient of x. So for equating, what I have to do, equation 1, I will multiply it by the coefficient of x in the equation 2. First, before going to this method, first you have to see whether these are in the general form, that is a1x, see, a1x, b1y plus c1 form. So a1x plus b1y plus c1 form. a1 is here 3, b1 is minus 5, and c1 is minus 1. So a1x plus b1y plus c1 equal to 0. a2x plus b2y plus c2 is equal to 0. a2 is 4, b2 is 1, and c2 is minus 9. So this form you have to bring first. If it is not given, then you have to rearrange the terms. Now equation 1 I will multiply with the 4. Equation 1 is here I am going to equate the coefficient of x. So I will multiply the equation number y by the coefficient of x from equation number 2. So equation 1 into 4 minus and equation number 2, vice versa. Equation number 2, I will multiply it by the coefficient from first equation, coefficient of x from first equation, that is 3. Equation 2 into 3 gives us, what it gives us, if multiply by 4, then 4 into 3, 4 into 3 is 12, 12x, 4 into 5 is 20y, minus 4 into 1 is 4 equal to 0, and then equation 2 by 3, 3 into 4 is 12x, 3 into y is 3y, minus 3 into 9 is 27 equal to 0. Now what I have to do, I have to decide whether, for eliminating the coefficient of x, whether I need to subtract or add. Here I need to subtract. So I subtract it. So this is minus, this will also become minus, this will become plus. So I got 12x minus 12x is 0, and this is minus 20, minus 3 is minus 23y, and plus minus 4 plus 27 is 23 equal to 0, minus 0 is 0. So this implies minus 23y is equal to minus 23. So this implies y is equal to minus 23 by minus 23, which is equal to 1. So by elimination method, I got the value of y as 1 earlier. By substitution method also, I got the value of y as 1. Now once I get the value of y is equal to 1, from here I will substitute the value of y. I have got already value of y equal to 1 in any of the equation. Here no restriction, you can put any of the equation in. I'll put say in equation number 1. In equation number 1, then I get 3 into x minus 5 into 1 minus 1 is equal to 0. Now simplify. So this implies thrice x minus 6 equal to 0. So this implies thrice x equal to 6. So this implies x equal to 6 by 3 is equal to 2. So solution is, we got x equal to 2. Answer, I got x equal to 2 and y is equal to 1. So in this way, the system of pair of linear equation in two variables can be solved algebraically by substitution method and elimination method. Another method is there, that is called cross multiplication method, that I'll discuss in the next class.